Started. These videos are not planned at all. I'm just doing them on the go, so if you find them useful, that's great. But I'll be stopping and reviewing the problems, so this might take a while. You can fast forward or whatever you want to do, but let's see how it goes. So this is one of the statics problems. I'm revisiting some of the problems that I've done throughout my engineering degree, and I'm just checking if I can still solve them. So let's see what this is all about. It says determine the magnitude and direction of the resultant force Fr. Okay, so we have three forces, F1, F2 and F3, and we want to add them all together and see what the result is of that. And we want to measure it counterclockwise from the positive x-axis, so that would be from over here. And how do we solve this? Oh, they specify specific steps as well. Solve the problem by first finding the resultant f prime, that's by adding f1 and f2, and then fr by adding f prime and f3. Alright, let's get cracking then. So let's first write out the vector formats for all of these forces. I think that will be a good place to get started with. So then it's F1, and I'll just make something at the top just to indicate that that's a vector. And F1 is 400 newtons. Oh, but it's a nasty direction and the angles are hectic. All right. First, let's make our own free body diagram then. So this is the y-axis, this is the x-axis. We have a force, F1, over here, and another one, F2 over here, and F3 is the easy one, that's straight down. Okay. Now the angles, that's the tricky part from this question. So this is a 90-degree angle. That's easy. So it's 150 minus 90, then we have a 60-degree angle over here. And this one is 90 degrees removed, so this is 60, then this is 30. Then this guy is 60 as well. And if we really want to be specific, we can make a dotted line, but also specify it over here. So this is then 60 degrees and this is 30 degrees. Great. Now we can go and write out the vector forms for each of these guys. So F1 is going to be, has a magnitude of 400, and we are going to times that by, in the x direction it is 30 degrees removed, so that's going to be cos of 30 and that is in the I direction. So I'm gonna indicate it like that, and then sine in the J direction, and this is again 30 degrees, little hat like that, and this is all newtons. Okay, now we need to see what it is all about. Cos is not the one. Sine is the easy one. Sine 30, that's a half. Cos 30, that's a little bit more tricky. and that's going to be root of 3 over 2. Times that by 400, and we get a value I'm going to tell you in a moment. That is 346.410 in the I direction, plus, and this is now half, so this is easy, this is 200 in the J, that's ugly J, in the J direction, and this is newtons. Great, so now we have F1. I'm going to do 6 significant figures up till the final answer, then I'll specify it in 4, which should be enough. Right, let's do F2. F2, let's go see what is it all about. Okay, so this is 60 degrees removed from the x-axis, and it has a magnitude of 200 newtons. Right, so we're going to say that's 200 times cos of 60 degrees in the I direction, plus sine of 60 degrees. This is again in newtons. Now, F2 is then equal to, let's see, cos 60, that is exactly the same as sine 30, so this is going to be 100 in the I direction, plus, oh, there I forgot something, critical. See, this is the fun part, because what most people never show you is how you actually go about solving these problems. They work out these things beforehand, and then they go back and they just show you the steps quickly. But problem solving is a lot more about figuring out where you went wrong and then fixing stuff. So it's a very iterative process. What I did wrong is I forgot. We specified the y-axis as upwards as positive, and the x-axis to the right side as positive. So F1 needs to have a negative component, and we completely forgot that. And the negative component is in the x direction, so it needs to be a negative in there. And I realized that because I then saw that F2 has positive components in both the x and y direction, and then F1 can't have that because it's not in the same quadrant. So yeah, all right, a little bit embarrassing, but okay, we'll make do. And then 200 times that's sine 60. Let's see, okay, 173.205 in the J direction, newtons. Great, okay, so we have the two vectors, the first two we need, and that's the F1 and F2. So then we can say that F prime is going to be equal to F1 plus F2. And then we just add up the components. So it's going to be equal to, let's see, let's do brackets like this, minus 346.410 plus 100 in the I direction plus F1 f1 is then 200 plus, let's see, 173.205 in the j direction, and then we can say that f prime, this is a fairly simple one, I'm just going to do that out of my head, is minus 246.410, the I direction. This one is positive, this is going to be plus 3, I think that was a 7, 3.205 in the j direction, and this is all in newtons. Great, so we've done the first step of this problem. I think that one is done. Great, now the next one, that's fr, and before we get to that we need to quickly put f3 in vector as well, but that's really simple. I should probably use this rather, it's less disorientating. Okay, f3, let's put that as a vector, and f3 is really simple because it has 0 in the I direction, and then it has a negative value. Now I just need to check the magnitude again. 300 newtons in the j direction. Great, so now we have f3, and then we can finally calculate the resultant vector. And the resultant vector is going to be equal to f prime plus f3. And then let's see how to do this. Okay, I'm just going to write it down immediately. I'm not going to do this in steps because it's too simplistic, I feel. Because you can see that the i's, they're just going to stay the same as they were in the prime case, so that's going to be negative 246.410, because 0 added to that does nothing in the I direction. And then I'm going to add the negative 300 newtons to the positive 370 something newtons, and that's just going to take that 3 away, so that's a 73.205. And this is exactly why I like to, when I want to specify at the end of a calculation something in 4 significant figures, I write it down throughout the calculation in 6 significant figures, because you can see sometimes we get rid of some of those significant figures, and then now there's 5 significant figures over here and 6 over here, and that should be enough to justify specifying our answer to 4 significant figures. Great. Yes, this is negative. Okay, so now we can see that if we draw another axis system over here, and then show the force, it'll be somewhere over here. Should look something like this. This is FR. This is the y-axis, this is the x-axis. FR should be somewhere over here, because it's a lot in the negative x direction and somewhat in the positive y direction. And we want to specify its magnitude as well as the angle. Let's call that angle theta. Okay, so magnitude, that's not too tricky. The magnitude FR, I'm going to write the magnitude like this. That's going to be equal to the x value. So that is, in other words, FR x component squared plus FR y component squared, and we take the square root of all of that. And I'm not going to write everything out now, I'm just going to type it into my calculator. That should be 246.41, that's a 0 squared, 73.205 squared, and we get out 257.054, but I'm going to write that as 0.1 newtons. So this is the magnitude of FR. And now we need to specify the angle. And the angle, the way we are going to calculate that, is we need to think about little triangles. So if we have a really general triangle, something like this, we want to calculate theta, then we can say that theta is equal to tan, and this will be arctan of, let's say this is a y value and this is an x value, and then it will be of the y over x. Yes, yes. Just had to quickly recall my my grade 10 knowledge for a moment. But yes, this is correct. And y over x. In other words, if we now look at this triangle and we take the y value, that's the positive y value now, and the x value, and I don't, you can go negatives, but I mean y, you're just making it more confusing for yourself at the end. You make a little triangle over here. You can see that we can easily go and calculate this angle, and let's call that psi. So in other words, theta will be equal to all of this, so this is 180 degrees, minus this little angle we specified over here. And we can rewrite that as 180 degrees minus tan, and it's arctan in this case, of the y side, and the y value of the force is going to be 73.205, 73.205, all over 246.41. And we'll write the 0 there as well. Great. Now let's see what angle do we get at the end. That's 180 minus arctan 73.205 all over 246.41. And then we get 163, and yeah, I'll do this to 4 significant figures as well. So that's 5 degrees. Great, and there we have our answer.